A cluster of thunderstorms can become one of the most powerful engines on Earth, but only when the ocean and atmosphere line up just right. The first ingredient is warm seawater. Tropical cyclones usually need ocean surface temperatures of at least 26.5 degrees Celsius or 80 degrees Fahrenheit, and that warmth must reach roughly 50 to 60 meters deep or 165 to 200 feet. Warm water evaporates, loading the lower atmosphere with water vapor. As that moist air rises into cooler air, the vapor condenses into cloud droplets. Condensation releases latent heat, which warms the air around the growing thunderstorms. Warmer air is less dense, so it rises faster, building deep towers of convection. That rising motion removes air from near the ocean surface, so pressure falls underneath the storms. Air from surrounding areas rushes toward the lower pressure. Those incoming winds blow across the sea, cause even more evaporation, and feed more moisture back into the system. This is the feedback loop that lets a tropical cyclone intensify while it stays over warm water. But heat alone is not enough. The storm also needs a way to remove air from its top. Near the top of the troposphere, rising air spreads outward in upper-level outflow, like exhaust from an engine. When that exhaust is strong and unrestricted, mass leaves the storm column efficiently, surface pressure drops, and winds strengthen. If outflow is blocked, the storm can stop intensifying. Rotation comes from the Coriolis effect. It deflects moving air to the right in the northern hemisphere and to the left in the southern hemisphere. Without that deflection, winds would rush straight into the low-pressure center and fill it. Because the Coriolis effect is very weak near the equator, true hurricanes almost never form within about 5 degrees of latitude. Wind shear is another key control. Vertical wind shear means winds change speed or direction with height. Developing hurricanes usually need low shear, generally less than 37 kilometers per hour or 20 knots. Low shear keeps thunderstorms stacked over the surface center. Strong shear tilts the storm, pushes heat away from the center, disrupts outflow, and can tear the system apart. Many disturbances still fail. Dry mid-level air can mix into thunderstorms and weaken updrafts. A capping inversion, a warm dry layer a few kilometers above the surface, can act like a lid and stop deep clouds from growing. When all the ingredients overlap, the process moves in stages. A tropical disturbance is first a loose area of thunderstorms. If storms persist, pressure falls and a closed circulation can form, making a tropical depression. As winds increase, it becomes a tropical storm. When maximum sustained winds reach hurricane strength, the system has become a mature tropical cyclone called a hurricane, typhoon, or cyclone depending on the ocean basin. The core lesson is simple. Hurricanes are not random walls of wind. They are heat engines powered by warm oceans, organized by rising air, shaped by Earth's rotation, and limited by the surrounding atmosphere.